Hello students. So let's see the formulae required to do the numericals in the chapter Work and Energy. Let's remember certain points. First important point is whenever you have numerical to be solved in the paper, then you should read the question properly. Try to understand it and try to find out which physical quantities are given in the question. Few quantities may be given directly and few may be given indirectly. So you should write down all the physical quantities which are given in the question. And then you should be knowing which physical quantity you are supposed to find out. So first you should write what is given. Now for this you should be preferably using the symbols. So you should know the symbols which are used for the physical quantities. Now the common physical quantities which will be used in this chapter are listed here. So U is a symbol for initial velocity, V is a symbol for final velocity, S is a symbol for displacement, or it can be distance also in case of straight line motion as distance and magnitude of displacement are equal. T is a time during which this velocity change takes place, or we can say T is a time during which force is applied. So F is a symbol for force, and A is the acceleration produced by this force. When this force is the force of gravity acting on the body, then this G is acceleration due to gravity. W is work done. P is power. E is a symbol used for energy. Sometimes we use EK for kinetic energy, EP for potential energy, or we can simply use E for energy. So kinetic energy, potential energy, or electrical energy, we can use the symbol E commonly for each of these different forms of energy. Now, after reading the question properly, after writing what is given by using proper symbols, after writing what is given means which physical quantities are given in the question, you should know what you are going to find, which physical quantity you are supposed to find out. So you have to use a symbol preferably and write here to find. Write the physical quantity that you are supposed to find out here. And you should write the formula which you are supposed to use and find out the given answer. Now, after writing what is given, what you're supposed to find out, which are the formula that you're going to use. You can write on maybe one formula or more formulae are required. After doing that work, you should first look at the things which are given in the numerical. You should see whether all are having proper units, or sometimes because maybe few physical quantities are in SI system, other is in CGS system. You have to see always that all the physical quantities which are given are having the units in the same system of units. So they are having, maybe all of them are having SI unit or CGS, but the system of units used for this should be same. So if any physical quantity is not having this unit which is in the same system, so you should do the conversion. So before we start with after writing the formula, before we proceed, we should see if any conversion is required in the given physical quantities to convert the unit into the suitable unit. Now let us see which are the formulae required in this chapter. So this is the first formula. Work done is force into displacement. W is F into S. Now the second formula, here we have kinetic energy. So here I have written EK is half mv square. Then we have potential energy. EP is equal to mgh. Then for power, we have power is equal to work done upon time or energy consumed per time taken. So we know the definition of power, work done in unit time or rate of doing work or rate of consumption of energy. Now from this, we can also write E is equal to P into T. For the numericals, which will be based on electrical energy, this formula will be used. Electrical energy consumed is power of the appliance into time during which the appliance is used. So here, remember one point, that whenever you have the question or numerical based on electrical energy, you have to use the power as in kilowatt and time in hour. Because you know the commercial unit of electrical energy is kilowatt hour. So power should be converted into kilowatt if it is given in watt, and time should be converted in hours. Now, all the formulae we have discussed, this is the last important point given in this chapter, work energy theorem. Sometimes you have to find out the work done, but there is no force given, there is no displacement given. Okay, and in no way you are able to find out the force applied or displacement produced from the given physical quantities. So please do not get confused, because there you have to use the work energy theorem. We know we have used this theorem for the derivation of kinetic energy also, and for the derivation of potential energy too. Work energy theorem, what is it? It states that work done on the body is equal to change in its mechanical energy, change in mechanical energy of the body. So this is equal to final mechanical energy minus initial mechanical energy. And you know mechanical energy is a sum of, you know that mechanical energy is a sum of kinetic energy and potential energy. Sometimes in the question only kinetic energy is changing. So in that case, the modified form of work energy theorem will be, work energy theorem states that work done on the body is change in kinetic energy. So final kinetic energy minus initial kinetic energy. Or the case may be that in the question the body is only lifted up, or its height is changed with respect to ground, and there is no velocity gained by the body. So in that case, work done on the body will be changed in its potential energy only. So depending upon the question, you should use this work energy theorem. So remember, work done on the body is change in mechanical energy of the body. This is a statement of this work energy theorem. Here remember that in case of the potential energy numericals, small g, acceleration due to gravity, should be taken as 9.8 meter per second square if not given in the question. If it is given that you take it as 10 meter per second square, then only you can take it as 10 meter per second square. Otherwise, you have to take the value as 9.8 meter per second square. In the numerical, if it is given that the body is initially at rest, you should know u is 0 meter per second. In that case, initial kinetic energy should be 0. Or if it is given that the body comes to rest or becomes stationary after the application of force, it means v is 0 meter per second, final velocity is 0 meter per second, and so final kinetic energy will be 0 joules. So students, you should not be scared of doing the numericals. If any numerical comes, you should read the question properly, write what is given, write what you have to find out, you write the correct formula. If you know all the formula in the chapter, you can choose a correct formula required here. Do the conversion required in the given physical quantities if it is required, and then just you put the values. See, first you should write the formula, okay, as it is. Then you should put the values and then do the substitution, cancellation, and write the final answer with proper unit. If you do not write the final answer with the proper unit, you lose marks. So writing wrong unit, you will lose marks, or writing no unit, then also you will lose marks. So write the answer with the proper unit, and preferably do not write the answer in fraction. You should write the answer in write the answer correct up to 2 decimal places, round it off to 2 decimal places preferably. Hope students, you have understood the formulae. You will remember the formulae required. You will remember the certain points which I have explained now. And no one should be scared of numericals, because even when you write the correct formula, if you do not get time, if you do not proceed, you can get the marks for the formula written if it is correct. So all the best to all of you. We'll continue with more tips, with more such informative videos. Goodbye.